Question 1. Given that x to the power of 6 divided by x to the power of a equals x to the power of 8, find the value of a. So when we divide our indices, we take away the powers. So 6 take away a must equal 8. So 6 take away what number gives us 8? It's negative 2. Part B. Simplify. 5b cubed times 2b to the power of 6 all over 3b to the power of 4. So if we do the top line first, 5 times 2 is 10. B cubed times b to the power of 6. When we multiply our indices, we add the powers. So 3 plus 6 is 9. So 10b to the power of 9 over 3b to the power of 4. And when we divide our indices, we take away the powers. So we can have 9 take away 4, which is 5. So we're going to have 10b to the power of 5 over 3. We can't simplify any further. 3 and 10 aren't in the same times table. We can't simplify that fraction any further. So we'll leave it as 10b to the power of 5 over 3. Part C. 2m squared to the power of 4. So 2m squared all to the power of 4. So we've got 2 to the power of 4. We could write it as 2m squared times 2m squared times 2m squared times 2m squared. We've got 2 to the power of 4, which is 16. 2 times 2 times 2 times 2 makes 16. And m squared to the power of 4 is m to the power of 8. So we've got 16m to the power of 8. 2a. Write 9,870,000 in standard form. So standard form is a number between 1 and 10. So we're going to have 9.87. And then times 10, how many times? Times 10 to the power of something. So 9.87 times 10 6 times makes 9,870,000. Millions are always times 10 to the power of 6. Part B. Work out the value of 9.2 times 10 to the power of 6 divided by 3.4 times 10 to the power of 8, and give your answer in standard form to 3 significant figures. So we can just type this into the calculator, exactly how it looks here, using the brackets. So 9.2 times 10 to the power of 6 divided 3.4 times 10 to the power of 8. And that gives us 23 over 850. Or as a decimal, I've got 0.027058 and so on to 3 significant figures. So we start counting at the first non-zero number, which is the 2. So 1, 2, 3 significant figures, and that rounds to 0.0271. That's not in standard form yet, so we need to write it as 2.71 times 10 to the power of, and it's divided by 10 2 times, so it's negative 2. And we can check our answer, or check both of these answers in fact, by typing our answer into the calculator, and it should convert them back to ordinary numbers, which it does. Question 3. Charlie invests £5,600 for 4 years in a savings account she gets 2% per annum per year, compound interest. How much money does Charlie have at the end of 4 years? So we've got £5,600, and we're going to add on 2% every year. To add on 2%, we multiply by 1.02. So we're going to add on 2%, and we're going to do it 4 times. So we're going to do it to the power of 4. So 5,600 times 1.02 to the power of 4. And that gives us £6,061. And we're going to round it to 2 decimal places because it's money, and 62 pence. So £6,061 and 62 pence. Question 4. A football team sell home shirts and away shirts. The ratio of home shirts to away shirts is 5:1. The home shirts can either be adults or children's, and the ratio of adults shirts to children's shirts is 3:2. What proportion of the shirts sold are children's home shirts? So one way of doing this is to convert these to fractions. So what fraction of shirts sold are home shirts if the ratio is 5:1? So there's 5 parts home shirts out of 6 parts in total. So 5/6 are home shirts. And the same for the children's and adults. So for children's shirts, there's 2 parts children's out of 5 parts in total. So 2/5 are children's shirts. So what proportion sold are children's home shirts? It's 2/5 of 5/6. And when we have of, we can change it to times. So it's 2/5 times 5/6. So if we type that into the calculator, that's 1/3. Question 5. The average house price in London in 2017 was £474,902. The average house price in London in 2018 was £469,538. Calculate the percentage change between 2017 and 2018. So percentage change is the change over the original times 100. So the change over original times 100. So let's work out what the change is going to be, them taken away from each other. So 469,538 minus 474,902. So that's going to be the change. That's going to be how much it's changed. And we're going to divide by the original, which was the 2017 amount, and then times by 100. So change over original times 100. So we're just going to type this in the calculator, and it will tell us the answer. And we've got minus 1.129496 and so on. It hasn't told us a certain number of decimal places or significant figures. So if we do 2 decimal places, minus 1.13%. Question 6. In London, potatoes cost 45 pence per pound. In Dublin, potatoes cost €1.48 per kilogram. And we've got the conversion between kilograms and pounds, the weight pounds, and we've got the conversion between the money pounds and euros. And we need to know in which city the potatoes are better value for money. So if we take our Dublin potatoes, so they're €1.48 per kilogram, and that means they're €1.48 for 2.2 pounds, because 1 kilogram is 2.2 pounds. So to find out for 1 pound, we're going to divide by 2.2. So 148 over 2.2, and that is 0.672 recurring per pound. So divided by 2.2, and that's 0.672727272 and so on. I'm going to leave that number in the calculator because I'm going to use it again. And I need to change the euros into pounds now. So to go from pounds to euros, we multiply by 1.15. So to go from euros back to pounds, we divide by 1.15. So the number in the calculator over 1.15, and that is, it's now in pounds, to 2 decimal places, that's 58 pence. So 58p per pound. And that's how much the potatoes cost in Dublin. In London, they were 45 pence per pound. So where are they cheaper? Where are they better value for money? It's in London. Question 7. Andy and Bruce share some sweets in the ratio 9:4. Andy gets A, Bruce gets B. Carla and David share the same amount of sweets as Andy and Bruce. They share their sweets in the ratio 5:2. Carla gets C and David gets D. And we need a ratio A to B to C to D. So we need the totals to be the same. So at the moment, A and B, this is 13 parts. And the C and D it's in 7 parts. So to put the ratios together, we need the number of parts to be the same. So we're going to times the A to B ratio by 7, and we'll times the C to D ratio by 13, and then they'll both be out of 13 times 7, so 91 parts each, and then we can put them together. So for A and B, it's 9:4, and we're going to times them by 7, so 9 times 7 and 4 times 7. For C and D, it's 5:2, and we're going to times them by 13, so 5 times 13 and 2 times 13. So now we've made the totals the same, both out of 91. We can say A to B to C to D is 63 to 28 to 65 to 26. Question 8. Here is a Venn diagram. So we've got A, B and C, and various numbers in the different sections. List the members of A and B, the intersection of A and B. So it's saying what numbers are in A and in B. So in A and B, we've got 1, 3, and 8. They're in the A circle and they're in the B circle. So it's 1, 3, and 8. The number is chosen at random from the whole set of numbers. Find the probability it's in the union of B and C. So the union of B and C includes every number in B and every number in C. So everything in the B circle is included and everything in the C circle is included. So how many numbers are in the union? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 numbers out of how many numbers in total? 12. So the probability we pick a number in the union of B and C is 10 out of 12. We could simplify that, we don't have to. Question 9. Adam is measuring the heights in centimeters of his tomato plants. And we've got a table here showing the heights, and we're going to estimate the mean height. So we don't know the actual heights of every plant, and that's why it's called an estimate. So we've got 7 plants between 140 and 150. So we're going to estimate that they are all the midpoint tall. So 145 centimeters tall. So if I've got 7 plants and they're all 145 tall, I've got 7 times 145, which is 1015 centimeters in total for all 7 plants. And I'm going to do the same for the next section. So between 150 and 160, I'm going to estimate. So I'm going to say they're all the midpoint, and there's 10 of them. So 10 155s, that's 1550. 160 to 170, the midpoint's 165. So midpoint times frequency, 2475. Midpoint times frequency, 175 times 19, 3325. And midpoint 190 times 9 is 1710. So I times across, I add down, so the total height of every plant added up is 1015 plus 1550 plus 2475 plus 3325 plus 1710. So the total height of every plant is 10,075 centimeters. And how many plants have I got? 7 plus 10 plus 15 plus 19 plus 9. So in total, I've got 60 plants. So the mean is them all added up, which was 10,075 divided by how many? There were 60 plants. So the mean is 167.916 recurring centimeters. I can round this, I don't have to. I will give my answer to 1 decimal place, 167.9. Question 10. 100 milliliters of liquid A and 200 milliliters of liquid B are mixed together to make liquid C. Liquid A has a density of 0.8 grams per milliliter. Liquid B has a density of 1.1 grams per milliliter. So we need to know density equals mass over volume. So our total density, so liquid C, density is going to be the total mass, which we don't know yet, we're going to have to work out, divided by the total volume, which we do know because it's 100 and 200, which is going to make 300. So we're going to have to work out the mass of A and the mass of B, and rearranging this, multiplying both sides by volume, mass is density times volume. So for A, for liquid A, the mass is going to be the density, which is 0.8, times the volume, which is 100. 0.8 times 100 is 80 grams. And for B, the mass is the density, 1.1, times the volume, 200. So that's 220 grams. So then the total density is going to be the total mass, which is 80 plus 220, over the total volume, which was 100 plus 200. So it's 300 over 300, which is 1. So the answer is 1 gram per milliliter. Question 11. Change 45,000 centimeters cubed into meters cubed. To go from centimeters to meters, we usually divide by 100. So to go from centimeters to meters, we divide by 100. There's a scale factor of 100. And volume, for volume, we use scale factor cubed. So to go from centimeters cubed to meters cubed, we have to divide by 100 cubed. And if it was area, the scale factor would be 100 squared. So it's 45,000 divided by 100 cubed, and that's 0.045 meters cubed. Question 12. Let's make these lines clearer. So we've got shape A as a regular triangle. So a regular triangle, an equilateral triangle. Shape B is a regular octagon. And we've got another regular polygon on the diagram. And we want to know how many sides it's got. So with our polygons, we can always work out an exterior angle for a regular polygon in it. So all exterior angles add up to 360 degrees. So 360, an octagon, so it's got 8 of them. So 360 divide 8. So each exterior angle is 45 degrees. So if an exterior angle is 45 degrees, an exterior angle plus an interior angle make 180. They make a straight line. So 180 take away 45 is 135. So an interior angle of an octagon, a regular octagon, is 135 degrees. For our triangle, an equilateral triangle, each interior angle is 60. So we can work out an interior angle of P by doing 360, because angles around the point add up to 360, take away 60, and take away 135. So the interior angle of P is 165 degrees. So we can work out an exterior angle of P. So exterior angle of P is 180. Take away the interior angle, and that means it's 15 degrees. So the exterior angle of P is 15 degrees, and all exterior angles add up to 360. So how many 15s make 360? And that's 24. So it must have 24 sides. Question 13. On the grid, shade the region that satisfies all of these inequalities. So we're going to draw 3 lines on the grid and then shade the region that works for all 3 of the inequalities. So we're going to draw the line y equals x minus 1. And to draw that line, we just need 3 points. So if I go 0, 2, and 4 for x. So if x is 0, y is 0 minus 1, which is minus 1. If x is 2, y is 2 minus 1. And if x is 4, y is 4 minus 1, which is 3. So I've got 0 minus 1, 2, 1, and 4, 3. So I'm going to draw this line. It's a solid line. It's a solid line because it can equal, y can equal x minus 1, so it's a solid line. If it was just bigger than or less than, it would be a dotted line. So I'm going to draw the line. I could rearrange this to make it y equals mx plus c, or I could just do it the other way around, have y and x. So if I pick the y values of 0, 2, and 4. So if y is 0, x is 6 minus 2 zeros, which is 6. If y is 2, x is 6 minus 2 2's. 6 minus 4 is 2. And if y is 4, x is 6 minus 2 4's. 6 minus 8 is negative 2. So I've got 6, 0. 2, 2, and minus 2, 4. So they all line up. And again, we're going to have a straight line going through these points. And my last line is x. I'm going to draw x equals minus 3. So x is equal to minus 3 all the way down this line. And I'm going to extend it to the edge of the page. So where's the region? I'm going to pick a point. So I'm going to pick a point. I'm going to pick 0, 0. And then if 0, 0 satisfies all of the 3 inequalities, I know it's the middle bit. So I could have gone above this line. So I could have said it's got to be above this line, above the first line. x has got to be less than for the second line, so to the left of this line, and x is bigger, so to the right of -3, so to the right of that line. So it's going to be the middle bit. But what I'm going to do to check, I'm going to have 0, 0. And if 0, 0 works for all of these, then I know it's correct. So if y is 0, x minus 1, well, 0 minus 1 is -1. So 0 is bigger than -1, so that's true. If x is 0, 6 minus 2 zeros is 6. So 6 is bigger than 0, or bigger or equal to 0, that's true. And if 0 is bigger than -3, that's true. So 0, 0 works for all three. So this point is in the region we're looking for. Question 14. Prove algebraically the recurring decimal 0.527 recurring can be written as 29/55. So we're going to call 0.5272727x. I'm going to multiply it by 10 to get something ending in 27 recurring. So 10x, and I need something else ending in 27 recurring. So that'd be 527.27 recurring, which is 1000x. So now I've got two things ending in the 27 recurring. So I can take away 1000x, take away 10x is 990x's. 527.27 recurring, take away 5.27 recurring is 127 take away 5, which is 522. Then I'm going to get x by itself by dividing both sides by 990. And we can use the calculator to simplify. And it simplifies down to 29/55, which is what we wanted. Question 15. Using xn plus 1, so the next term is equal to the cube root of 9 plus 8 times the previous term, and we're starting with 3, find the values of x1, x2 and x3. So to find x1, we're going to have the cube root of 9 plus 8 times 3. So we're going to put the first one in, and we will see what we get out. So it's the cube root of 9 plus 8 times 3. So I've got 3.2075343. So that's x1. And then to find x2, I'm going to put that answer in. So instead of 3 this time, I'm going to have my answer, which is 3.207534333. I'm going to use the answer button on the calculator instead of writing out that number. So type it in, or just change the 3 to the answer button. And we get 3.260448413. And one more time for x3, we can just press equals again. So we don't have to change anything on the calculator, just press equals one more time. And that's 3.273668,236. Question 16. The flight from London to Dubai takes 7 hours to the nearest 10 minutes. So we've got a bounds question. The distance from London to Dubai is 3,400 miles to the nearest 100 miles. John says the average speed, so speed is distance over time, is definitely less than 500 miles per hour. Is John correct? So we need to know the upper bound for speed, which is going to be the upper distance divided by the lower bound for time. So let's look at our bounds. So for time, we've got 7 hours to the nearest 10 minutes. So the one below is 6 hours 50 mins. The one above is 7 hours and 10 minutes. So the lower bound is 6 hours 55. And the upper bound is 7 hours and 5 minutes. And for distance, it's 3,400 miles to the nearest 100 miles. So below is 3,300, above is 3,500. So the lower bound is 3,350, and the upper bound is 3,450. So we're going to use the upper bound for distance and the lower bound for time. We need 6 hours 55 minutes in hours. So 55 minutes. So minutes are out of 60. So 55 sixtieths. So it's 6 plus 55 sixtieths. And that comes up as 83 over 12 hours, or 6.916 recurring. So I'm going to leave that number in the calculator. So my upper bound for speed is 3,450 divided by my 6.916 recurring, which is in the calculator already. So 3,450 divide answer, and that comes out as 498.795 and so on miles per hour. So is the average speed definitely less than 500? Yes, it is. So is John correct? Yes, John is correct. Question 17. So we've got a speed time graph, and we're going to work out an estimate for the acceleration when t is 4. So acceleration on a speed time graph is the gradient. So we need to draw a tangent. So it's a tangent, a line that just touches at 4 seconds. And we're going to work out the gradient of this line. So let's pick 2 nice points. So I've got 0, 22, 0, 22, and we'll go with this one, which is 850. So gradient is the change in y over the change in x. So if we've gone from 22 to 50, 50 take away 22. And we've gone from 0 to 8. So I've got 28 over 8, which is about 3.5. So you'll have numbers similar to that. Obviously, you probably won't draw exactly the same tangent I have, so it'll be slightly different, but there'll be a range of acceptable answers. And part B, use 5 strips of equal width to find an estimate for the distance travelled in 10 seconds. So the distance travelled is the area underneath the graph, and we're going to split it into 5 strips. So we'll have a triangle, and then we'll have some trapeziums. So we're going to work out the area of each of these shapes and then add them up. So we've got a triangle. So the area of the triangle is half times base times height. The base is 2. The height we're going to say is 26. Let's just work out the lengths first. So this is 36. 41, 44, and 45. So triangle, half times base times height, half times 2 times 26, which is 26. We've got a trapezium, so it's the half the sum of the parallel sides, so 26 and 36. The average between 26 and 36 is 31 times 2. 31 times 2 is 62. The average between 36 and 41 is 38.5. 38.5 times 2 is 77. The average between 41 and 44 is 42.5. 42.5 times 2 is 85. And the average between 44 and 45 is 44.5 times 2 is 89. So I haven't written down any working, which I should have done. But my total area is going to be 26 plus 62 plus 77 plus 85 plus 89, which is 339 meters. And again, there'll be probably a slight range you can have there, where some of these points weren't exactly on the line. Question 18. So we've got a cuboid, ABCD, EFGH. ABCD is a square with area 25 centimeters squared. Because it's a square, we know that the lengths must be 5, because 5 times 5 makes 25. The volume of the cuboid is 190. So we can work out the length. So 25, the area of the cross section, times the length equals 190. So the length is 190 divide 25, which is 7.6, and it's centimeters. So we know it's 7.6 centimeters. So we know the dimensions of the cuboid. The question says, find the length of the diagonal AH. So A to H. So diagonally across the shape, So we're going to have a right angle triangle floating in the air like so. So we've got a floating right angle triangle in the air. We know this height is 5. We don't yet know the diagonal along the bottom, but we can work it out using Pythagoras. And then we'll use Pythagoras again. So it's 3D Pythagoras. And the quick way, so to get from H to A, it's out 5, along 6.5, and up 5. So there's 3 different directions there. So it's 5, 5, and 7.6. You square them all, add them all up, and square root. So for 3D Pythagoras, there's 3 directions to travel to get from one point to the other, and we just square them all, add them up, and square root the answer. 5 squared plus 5 squared plus 7.6 squared, all square rooted, and we're getting an answer out to 3 significant figures of 10.4 centimeters. Question 19. So we've got a badge formed of a sector and a triangle. So O to A, so the radius is 3 centimeters. O to B is also a radius, so that's also 3 centimeters. OAB is 25. And again, because we've got an isosceles triangle, OBA must also be 25. Because we've got 2 radiuses, so an isosceles triangle has 2 lengths the same, and the 2 angles at the base the same. And we need to work out total area. We're going to work out these angles here. So angles in a triangle add up to 180. So take away the 2 25s. So we've got 130 degrees as the other angle in the triangle. And we've got 230 degrees. Angles around the point add up to 360 as the angle of the sector. So we've got 2 parts. We've got area of a triangle, area of a sector, and we add them up. So area of triangle, we can use half AB sine C, half AB sin C. And A and B will both be 3, and the angle is 130. So it's half times 3 times 3, and sine 130. So half times 3 times 3, sine 130. So we've got 3.4471999 and so on. We'll store that in the calculator to use in a minute. And we've got the area of the sector. So it's 230 degrees out of 360 degrees. So that's the fraction of the circle we've got. And it's times pi r squared. So the area of the whole circle is pi r squared. And we've got this fraction of it. So 230 3/60ths of pi times 3 squared, which is 23 over 4 pi, or 18.064157776, and so on. So for our total area, we're going to add up the 2 parts. So I've stored the number in the calculator. So I'm just pressing answer plus my stored number. So that's 21.51135775. And we haven't been told a certain number of decimal places, so I'll just give it to 1 decimal place. Question 20. Here are 9 graphs. So we've got different graphs, and we're going to be asked to match equations to graphs. So let's look at each of these graphs and look at what kind of equation they're going to have. So graph A and graph B, they're exponential graphs. So graph A is something to the power of x. Let's just use 2. It might not be 2, but y equals something to the power of x. And graph B is an exponential graph, but reflected in the y-axis. So it's something like y equals 2 to the power of minus x. Graph C is a quadratic graph, and so is graph F. So graph C is a positive version, so it's something like x squared minus 4. And graph F is a negative x squared, so it's something like y equals negative x squared plus 4. Graph E is a circle, so it's x squared plus y squared equals the radius squared. Let's just call it 4 again. Graph D is the tan graph, y equals tan x. Graph H is the sine graph, starts at 0, so y equals sine x. G is the sine graph reflected in the x-axis, so y equals minus sine x. And I is the root x graph, so y equals square root x. So let's look at the letters. So 2 sine x, our sine graph was h. X squared plus y squared equals 10. That's a circle. And that's E. Y equals 2 to the power of x, a normal exponential graph, which is A. And the tan graph was D. Question 21. Here are the first 5 terms of a quadratic sequence. So a quadratic sequence is one where the second difference is the same. So it's going to have an nth term in the form something n squared plus something n plus something, a quadratic nth term. So let's work out the first difference. So it goes up 4, 7, 10, 13. And then the second difference, 3, 3, 3. So to work out the nth term, we can remember that this second difference is 2a, where a is the number in front of the n squared. We can remember that the difference between the first and second term is 3a plus b. And the first term is a plus b plus c. So if we remember that, we can just solve these equations. So 2a is equal to 3. So a is 1.5. 3a's plus b is 4. And a is 1.5, so 3 1.5s. So 4.5 plus b equals 4. So b is minus a half. And a plus b plus c equals 4. So 1.5 minus 0.5 plus c is 4, which is 1 plus c is 4, So C is 3. So the nth term is 1.5 n squared minus 0.5 n plus 3. And we can check our answer. So if you substitute in 5 in for n, you should get 38. If you substitute 3 in for n, you should get 15, and so on. So if you substitute 5 in for n and see if you get 38, you know you've got the right answer. Question 22. So we've got information about the speed in miles per hour of 120 cars, and we're going to draw a histogram. So for a histogram, we're going to have the speed along the bottom in miles per hour, and that starts at 40 and goes up to 90. So 40, 50, 60, 70, 80, 90. And up the side, we're going to have frequency density. So we're going to work out what the frequency densities are before we draw the scale up the side. So frequency density. So frequency is the area of the bar. Frequency density is the height of the bar. And the width, well, say 40 to 55 has got a width of 15. 55 to 60 has got a width of 5. 60 to 65 is 5. 65 to 75 is 10. And 75 to 90 is 15. So if we know the area and the width, we can work out the height by doing area divide width. Or frequency density is frequency divided by class width. So 6 divided 15, 0.4. 10 over 5, 2. 46 over 5, 9.2. 48 over 10, 4.8. And 6 over 15, 0.4. So we need frequency density to go up past 9.2. So we'll have 2, 4, 6, 8, and 10. So we just need to draw the bars on now. So 45 to 55 goes up 0.4. 40 to 55, 40 to 55, and goes up 0.4, which is 2 of these little squares, like so. 55 to 60 goes up 2. 60 to 65 goes up 9.2. 65 to 75, 4.8. And 75 to 90, 0.4. Work out an estimate for the number of cars over 70 miles an hour. So we're going to 70 miles an hour, which is here. So I'll cut that in half. And to work out how many cars, we can do base times height. So 5 times 4.8 is 24. And that should be 6, which it was. So how many cars over 70 miles an hour? 24 plus 6, 30. Question 23. A, B, and C are points on the circumference of a circle with a radius of 4 centimeters. AB is a diameter, so a diameter goes through the center. CD is a tangent to the circle at C. And we need to find the size of angle CAB. CAB. This is what we're working out. So we know a tangent meets a radius at a 90-degree angle. So tangent meets radius at a 90-degree angle. And C to D is 10 centimeters. The radius is 4 centimeters. So we can work out the size of this angle. So let's call that Y. So we can use SOHCAHTOA to find out the size of angle Y. So the hypotenuse is the longest side. Opposite the angle is 10. And in between the angle and the right angle is called the adjacent, which is 4. So SOHCAH and TOA, we're using O, which is 10, and A, which is 4. We're not using H, so it's not SOH or KA. We're going to use TOA. So that's tan with the angle equals O over A. So tan Y equals 10 over 4. So the angle is arctan 10 over 4. So we're just going to type that in the calculator. And that gives us 68.19859 and so on. So that's the angle Y here. How can we find X? So there's a few different ways. We could use another circle theorem. So we can say the angle at the center is twice the angle at the circumference. So we can half our answer, and that will tell us X, because they're both from the same points. The angle at the center is double the angle at the circumference. We could have also used the isosceles triangle here and worked out the angles that way. But all we've got to do, 68.1985 and so on, divided by 2 to 3 significant figures is 34.1 degrees. Question 24. Solve algebraically the simultaneous equations. So we need to use substitution to solve these simultaneous equations because it's quadratic. So we're going to rearrange the second equation to either make it x equals or y equals. And the quickest way to do that would be to plus 2y to both sides. So x equals 5 plus 2y. So if x equals 5 plus 2y, we can change the x's in the first equation into 5 plus 2y. So we're going to substitute in wherever we've got x, we're going to change it to 5 plus 2y. So we're going to have to expand these brackets. So let's do that. So I'm going to leave the 2 there, and I'm going to leave a bracket. I'm going to have to multiply everything by 2 at some point, but I'm going to expand the double brackets first. 5 times 5 is 25. 5 times 2y is 10y. 2y times 5 is 10y. And 2y times 2y is 4y squared. Then I've got negative 3 times 5 is negative 15. Negative 3 times 2y is negative 6y. And I've got a minus 7 on the end. So I'm going to collect the like terms in the bracket first. So 10y and 10y is 20y. Could have collected like terms there, but I haven't. Now I'm going to double everything in the bracket. So 2 25s are 50. 2 20s are 2 20y's are 40y. And 2 4y squareds are 8y squared. Now I'm going to collect the like terms. So I've got 8y squared. That's the only y squared term I've got. I've got 40y take away 6y, which I'm going to leave the y on this side for now. So I've got 34y at the moment. And 50 minus 15 minus 7. So 50 minus 15 is 35. 35 minus 7 is 28. And I've got take away y from both sides. So I've got a quadratic equal to 0. And I'm going to solve it using the quadratic formula. So y in this case equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So a is 8, b is 33, c is 28, and I'm just going to substitute these in. So I'm going to use brackets. So every time I've got a letter, I'm going to change it to brackets and put the right number inside. All over 2 8s. So I'm just going to type this in the calculator now. Exactly how it looks. Apart from, I'm just going to do the plus first, and I'll do the minus after. So I'm just typing it in exactly how it looks. I'm using the brackets as they are. So for my plus answer, I've got minus 1.194222251, and I'm going to store that and keep it in the calculator. And then for my minus answer, so I'm just going to click back into the calculator and change the plus to a minus. So I've got minus 2.930777749. And I'm also storing that in the calculator. So I know x equals 5 plus 2y. 5 plus 2 of these. And I'm going to have 5 plus 2 of these. So I've stored the numbers in the calculator. So I'm not worried too much about putting the whole number in here. So 5 plus 2 of the first one. So x can be, I'm giving my answers to 2 decimal places. So x is 2.61 when y is minus 1.19, and x is minus 0.86 when y is minus 2.93. So I've got 2 different answers, and that's done.